morning, welcome back to the Rollup. Today's episode is with our friend Arjun with Everclear, formerly known as Connext. And Everclear is the first Rollup clearing layer. These guys are building chain abstraction. They've been thinking about chain abstraction and intents for a really long time, pioneering the terms back when they were Connext. And Everclear is now a fresh new take on chain abstraction, which we believe at the Rollup is the solution to the modular fragmentation problem. Before we get into today's episode, first a word from our sponsors. Cartesi is your home for app-specific rollups. At the forefront of developing new tools and platforms that enhance the capabilities of blockchain technology, Cartesi enables applications that are flexible and built to scale. Build on a full Linux environment and use traditional software libraries, but in blockchain development. Go to cartesi.io, that's cartesi.io, to learn more about building your own app chain today.
Welcome back to the Rollup. Today we have our friend Arjun from Everclear to discuss the clearing layer, chain abstraction stack, maybe some cross-chain MEV, some modularity tossed in there a little bit as well. Arjun hasn't been sleeping, so bear with him. But welcome to the pod, sir. It's good to have you back.
Thanks so much. I appreciate being here. Generally super excited for this conversation.
Awesome, man. Yeah, I mean, congrats on the upgrade, the launch, whatever you want to call it. No longer Connext, now Everclear. Generally, yeah, congrats. I mean, how do you think things went?
Yeah. Honestly, I mean, it like hugely surpassed our expectations. This is something we've been like preparing for quite a while. We really wanted to like nail the like messaging around it. It's a fundamentally new concept, and this is not the first time that we've like introduced new ideas to this space. We've actually very often been the first to do a bunch of stuff in the space. We've like deployed the first L2. We like built the first intent-based bridge. We introduced the concept of like modular bridging and stuff like that, and chain abstraction. But I think historically, one thing we haven't done a great job of is like making sure that from day one, there's like a very, very clear picture of how this works, and like a very, very clear understanding of like what exactly does this solve and like how does it solve it. And I think this time we really doubled down on making sure that right out of the gate, there's like a consistent way to talk about Everclear and around clearing in general for this space. And it seems to really have paid off. Like a lot of people, you know, like I went into the launch super nervous because I was like, you know, this is a really technical topic, and like, are people going to get it? You know, I was expecting it to kind of go in the direction of something like restaking, where like it took a while for people to get restaking, right? Even though it's such an important primitive. But honestly, we've kind of had the opposite experience where like a ton of people just organically reached out to us or just like co-promoted the content or kind of talked about it publicly because they were all just like able to understand, you know, the original tweet thread, the original blog post, to the point where they were able to talk about it, which is kind of cool.
Just before we get into it, like, where do you keep getting all these like original ideas?
Honestly, I think it's just like the kind of person that I am. You know, there's good and bad things about this. I tend to be the kind of person that like really thinks really far ahead on things, and I'm also really oriented towards like trying to find new problems to solve or new ways to solve problems that people haven't thought of before, or like new ways to think about problems from like first principles, rather than competing on a head-to-head basis with other projects. Like I just in my personal philosophy is like, okay, if there's going to be like 20 projects trying to solve XYZ problem, like there probably doesn't need to be 21, and like effectively you can consider that problem solved unless someone has like a genuinely different way to do things, or unless there's like a way to kind of rethink the market from first principles. So I think a part of it is just that like we're as a team, we're like really not afraid to just like kill our babies, and we have like rebuilt the whole system so many times in like so many different capacities for so many different reasons, and like we're not really afraid to do that because each time you do it, it gets like so much better. You learn so much more about it. But I also recognize that that's not how most teams operate, and there are tons of downsides to that too. Like we've not always, but we've often been very early to things, like sometimes to the tune of like years early, because you know if you're thinking ahead, you're not necessarily looking at like where the market signals are today.
Yeah, and you guys, I think it was arguably you could say that you guys were years early to chain abstraction, and now like that's coming to the limelight. So like, yeah, I mean, take us through like your train of thought from, having that chain abstraction idea originally, coining that term, to ultimately killing that baby, that Connext baby, and now like birthing a new baby in Everclear.
Yeah. So I think it comes down to like what our background was. So like when we first started really building stuff in the space, the whole thesis was like, how can we make Ethereum simple enough that anyone can use it, right? Like I think we were one of the first teams to start talking about this idea of like, how do we scale to 1 billion users? And that for us, that meant not just like the technological scalability of the blockchain, but also like the user experience of like it is actually usable, right? And I think like we were like when we were doing a bunch of L2 research with other folks, we kind of saw like, okay, well, there's a bunch of different hypotheses around how to build L2s, but like everyone's philosophy was like, okay, there is going to be an L2, not like obviously some people were thinking of it as like there will be a project, but in our minds that was like there is going to be an L2 ecosystem that needs to be unified. It needs to appear as if it's like one single system. And so when the space started going in like 2020 or so, it started going towards like, okay, there's going to be like dozens of different rollups. For us, it was like, okay, well, there's clearly something missing here, which is this experience of like, it should feel like a single unified rollup. It shouldn't feel like there's so many different options. And I think we started talking about that in 2021. Like, we kind of had a bridge UI then, and that was taking off, but that was just something that had like been built on top of the system, and it wasn't something that we cared about. Now, this was an example of a case where it was a bit of a mistake, where like, in 2021, what we probably should have done was just like focus on being the best bridge instead of focusing on the thing that we actually did, which was like trying to convince a bunch of applications, hey, like stop making your users bridge, just like give them a single experience where you deposit into your system from any chain. Like, why are you sending them to another UI? You're losing like 80% of your conversion as a result of it. But it was the bull market, and like people didn't necessarily care at the time. And like there were other problems, bigger problems that were like worth solving then for those ecosystems rather than trying to solve this one. But it's like for that kind of thing, it's like it's only a matter of time, right? We knew that at some point we were going to hit this same hurdle. Like applications are going to hit the same hurdle of, okay, I am having to like I'm Aave, and a user has lent a bunch of tokens into a pool on Arbitrum, and like they want to move that to Optimism. I'm going to go send them out of my app to some completely different application to go do that. And they might have a really terrible experience that I just can't control at all. And then I'm going to tell them to come back. And like, will they come back? Probably not. So we kind of realized like at some point that has to change.
Yeah, that's the thing. In 2021, the opportunities were so fast, and everything was going so crazy that bridging was just like it was something that you would do. Um,
Yeah.
and yeah, trying to. I remember like in Paris, even last year, the chain abstraction toolkit idea. It was still something that teams were kind of accepting, but like it was still like kind of new. But now
Yeah.
push towards Everclear. So maybe we can talk about how you're visioning the chain abstraction stack, and kind of why Everclear is a core part of that stack. And kind of one thing that we're starting to realize big time with conversations from leaders in the space for chain abstraction is it's very much so a collaborative effort in terms of their ideas for how we're going to kind of make this happen. So like it seems like this with the idea of the clearing layer is like very much so focused on one part that if done very well can be perfected and can help the broader space. So maybe you can kind of shine light on this broad idea here.
Yeah. So to do that, I guess let me talk a little bit about like some of the challenges that we experienced with the chain abstraction toolkit last year when we released that. Um, as you mentioned, like it was something that was really interesting to a lot of developers, but not everybody jumped on it. And like we saw that there were two reasons for that. The first was the market just wasn't there yet. Like, every developer, every project we talked to was like, yeah, this is something that we like actually need. Like we want to be able to expand to more ecosystems. We want to allow onboarding for users from more ecosystems. But right now we're just struggling to like just keep the lights on because this was still the bear market. People were it was just like everybody was in the like Maslow's hierarchy of needs. They were just trying to feed themselves. And and I think that was kind of like one key problem where we're like, okay, this is something where like we just have to kind of wait until these projects grow a little bit, and then it makes more sense. The other thing that was an interesting catalyst is something that really like catalyzed that change was like what happened with Renzo. I think Renzo was the first protocol to really just go all in on this idea of you know what? If you make it really easy to restake, that is such an enormous competitive advantage to be able to do it super easily from every other chain that like that in and of itself can be like a massive differentiator and driver of growth. And that thesis ended up being super correct. Obviously, in retrospect, it makes sense, right? Like, and this is something that we and many other people have been advocating for a while. But like, I think for most application developers, there was just no way to test this or validate that, like, I'm going to grow more by making it super easy to onboard from anywhere versus like trying to double down on like the Arbitrum ecosystem or whatever ecosystem I'm in right now. The other reason that we struggled was actually the reason that Everclear kind of ended up getting created, which was we realized, okay, if you want to go support applications to onboard from any chain, and you're talking about DeFi applications, ideally they want to work with any asset, and there's like a growing number of chains and a growing number of assets, this just becomes an extremely complicated problem really quickly. And like we realized that there was fundamental limitations to how quickly we, as a bridge protocol, could get everywhere with liquidity, right? And so we realized, okay, this is maybe too big of a problem for one single project to solve. Like this is kind of where I've ended up personally. Is like I really don't think that there's a world where like there's going to be one intent protocol that might just deploy every single chain. Like it's just too much overhead, and like rebalancing especially is like the big piece of that. Like how do you get liquidity back? It's a big piece of that. Like no one really has an answer to. And so we kind of, in the process of thinking about that, we started thinking through like, okay, like after we released the chain abstraction toolkit and talked with a bunch of people, tried to do some integrations, we realized, okay, we need to get to the point where we can support like onboarding from literally every single chain. And to do that, we need to solve this like underlying clearing rebalancing problem. And so the more we kind of like double clicked on that and started focusing on that, the more we realized, okay, you know what? This is basically the same problem we've been thinking about now for 3 years since 2021. And that this is such a big, hairy problem that like every single intent protocol is just also going to run into it. And like, it's kind of the same thing as like, I guess this is really how you find like most of the interesting opportunities is like we just kind of double clicked enough till we got to something where we're like, okay, there just isn't an answer for this. And like, it's such a huge problem that everybody's going to have to deal with it. So I think the second part of your question was like, how does this actually like fit in? What problem does it solve? I've kind of alluded to it a little bit already, but like, in effect, when you're making intents happen across chains, what's really happening behind the scenes? Basically, you're like there's semantic debate as to like how you kind of define this and things like that. But like in effect, right now, what most people mean is that there's a user describes something that they want to do, and some third-party service provider comes and does it on their behalf. So like literally think of TaskRabbit, right? Or like Uber, or like Bolt, or whatever, any other service app where what you're doing is renting someone else's time and expertise and sometimes their like vehicle or whatever it is that they can provide to do the thing that you want to do. That's effectively all that an intent solver is. They're just sort of like providing this stuff. They're taking on the complexity and providing liquidity as a service. The challenge for intents and intent solvers is really simply like, if I am trying to go and deposit 100K of liquidity, and I have my liquidity on like Gnosis chain, and I want to go deposit that into Aave on Arbitrum, it's super easy for some third-party service provider who has 100K of liquidity to go and do that on my behalf, right? So they're just fronting their own capital. They deposit into Aave. That can happen in seconds, right? We've all seen how incredible of an experience it crosses. Like it's a magical experience. Someone else can just do it on your behalf. It can happen at web native speeds, right? I'm certain that we can get this down to like sub-second speeds over time. So what is the core problem? Well, for you as a user, there's no real problem, at least in this instance. But for the solver, now the solver has ended up in this position where they have paid 100K of their own liquidity. They need to be repaid by the intent protocol. How does the intent protocol repay them? Well, the only funds that the intent protocol has are my original 100K back on Gnosis chain. So what will any intent protocol do? It'll repay the solver back on Gnosis chain. And so now the solver who had 100K of liquidity on Arbitrum has 100K of liquidity on Gnosis chain. That is very meaningfully different situation to be in, right? Like there is a ton of inflows coming to Arbitrum all the time. Like that 100K is going to get used up constantly, but who knows what might happen on Gnosis chain? And like, who knows, if a user's onboarding from some like totally long tail, like L3, the solver's liquidity could just end up somewhere and like, they're just stuck, right? There's no way to get out of that. So how is this handled currently? For a limited number of chains, really like the top 8 chains or so with the top like 2 to 3 assets, solvers basically just muscle through it. They like build if what is effectively like an in-house aggregator. They'll like connect to a bunch of bridges. They'll connect to like OTC desks, exchanges, centralized exchanges, etc. And they'll just try to figure out some way to get their funds back. And they'll bake this into their pricing, where they're like, okay, like based on the pricing that I'm able to give, like this is how much it's going to cost me to rebalance. And this is complex, obviously, like operationally. Every time you add a new chain, you have to do all of these integrations. You have to think really carefully about pricing, stuff like that. And it's also like this is where the kind of centralization vector comes in. So actually, immediately before recording, we started talking a little bit about this, but there is this like economies of scale that you get here, where like if you're a larger solver that has tons and tons of money, say for example you didn't just have this 100K that you're routing from Gnosis to Arbitrum, but you actually had $100 million sitting on Arbitrum and Gnosis chain. Well, do you care so much about rebalancing right now? No, not really, right? Like you're just going to keep the money there. Fine, some of it's not getting used, but it's a small percentage of your total capital, so you just kind of leave it there and you'll deal with it later. And in theory, at some point in the future, because you're like less time sensitive about rebalancing, at some point in the future, someone may make a transfer from Arbitrum to Gnosis chain, your funds can end up going back. So this is called netting, where like you have bi-directional funds that kind of like flows that cancel each other out. And who can net really effectively? The big solvers, right? Like Wintermute can net really effectively because they have so much money that like for them, it doesn't really matter. Who can't net effectively? Any indie solver. And so now you can see why we have this like world that we live in today, where there's like not really that many solvers operating very successfully, and they're still only serving like the top few chains. So this was the kind of core problem that we saw. We were like, how do we get to the point where anyone can run a solver on any chain with any asset, and they can do this in a way which is like economically feasible, right? Where it's not just okay, we're going to explicitly operate this at a loss because there's no other way to make it work. This is the core problem that Everclear solves. How does it solve it? Well, we already kind of looked at the solution, right? Like the Wintermute has the solution. How do they solve it? They have tons of capital and they just like net out their flows between chains. And because they're netting out of all of these flows, they're dropping their costs of like rebalancing down per transaction, like they're amortizing it per transaction, down to the point where they're able to be super competitive, right? They can give better pricing than anybody else on these intent-based bridges and dexes, and overall they can kind of like win the market. So the way to kind of emulate that is to allow for a bunch of smaller solvers, or really anybody, to be able to net off between each other in the same way that Wintermute nets off their own capital. And so what this means is this allows like anyone who wants to kind of use Everclear and net off their settlements to have the same economics as a larger player, like Wintermute. It effectively fixes the kind of centralization risk of solvers.
So, okay, but how? Like, let's do an example. Yeah. Okay, so like Rob and I we have $10,000 and we're participating in the clearing layer of Everclear. Like, are Rob and I interacting with each other, like aggregating like a pool of funds and then going to work to like compete with the solver, or is it like, am I adding mine in with the other solver, or like kind of how does a smaller player like us get to participate and also like win the auction, like to beat out a bigger player?
So let's talk about that a little bit, because we alluded to a few different things. So you mentioned auctions, right? Auctions are basically the process by which a solver gets selected to fill an intent. So this is basically like when you click, find me a ride on Uber, there is like, it kind of is pending for a while and then it matches with a driver. That's the auction. The process that we're talking about with Everclear is not how do you get that. It's after the driver drops you off, how do they get back home, right? How do they get back to somewhere where they can continue picking up rides? So just want to make that piece clear. Now, the interesting thing is the amount that a driver needs to like drive to get to another place where they can pick up another ride determines their cost basis, right? Like if they're having to drive, like if you took an Uber out into the middle of the desert for an hour and then they had to drive an hour to get back, they're having to pay gas and all of this time on the way back where they're not earning any money. And so, in theory, their cost basis has gone up. Now, I don't really know how Uber handles this, but if we want to handle this in like an open, decentralized, fair system, like then in theory, the Uber should be charging a higher price for the next ride that they do, because it costs them so much more to get back to where they could even do that right in the first place. This is kind of how intent solvers work. It's like the solver has to charge a higher price. If they ended up with funds somewhere totally random, they're going to have to charge a higher price to offset that. The how it happens is an interesting question. And basically this comes down to almost like cow swap like coincidences of once, right? So this is what netting is. Netting basically is a concept where, say for example, Andy, you were a solver and you made a transaction happen from like, Optimism to Arbitrum. Robbie did one from Arbitrum to Polygon. I did one from Polygon to Optimism, right? So Andy, because you did Optimism to Arbitrum, you paid funds on Arbitrum, you ended up back on Optimism, right? With your funds. Now, ideally, like say, for example, you're a solver, you're like, I don't actually really want to work with Optimism at all. I only want to work with Arbitrum. I'm going to have to go and rebalance my funds. Robbie kind of has to do the same thing where he's like, okay, well, I, received this transaction on Arbitrum. I wanted to end up over here. And you can see how like we all kind of ended up in the same position where we all ended up with funds in a different chain than we initially anticipated. What's really interesting here is that Andy, you ended up with funds on the chain where I want funds. Robbie ended up in the funds chain where you want funds. And so like it's kind of a loop. If we all communicated with each other, if we had a platform to talk to each other about it, where we could all just say, okay, well, I have 100K on this chain, and I want it over here, and we all just said that and put it in the middle, then we could coordinate with each other to just basically just like swap with each other directly on the same chain without ever having to like really go and rebalance funds in the first place. And that happens at effectively zero cost. The mental model here is if you guys have used Splitwise, that's a really good analogy, because what is Splitwise doing? Splitwise is an app that like allows you to split a bill or something like that with your friends, right? And like what you all do, you and your friends, you go on a trip or something, everybody just registers the amount of money that they've paid for stuff, right? And like, or the amount of money that they owe to each other. And at the end, Splitwise aggregates all of that and just gives a final amount. So my final amount can be, I owe, Robbie $10, even though, technically Andy owes me and I owe Andy and Andy owes, it's like, it basically is reducing all of this, like tons of transactions down into like a final amount that everybody actually owes each other. And as it turns out, that this was something that really shocked us when we started looking at the data. We had this like hypothesis around netting, because we were like, okay, there has to be like a certain amount of netted value in the space, right? The thing that shocked us was when we started looking at the data, that number on a daily basis, that number is 80%. So 80% of the flows between chains like net out based on like public flows. This is not even including the private flows, where if you include like centralized exchanges, OTCs, things like that, that number is probably close to 90. What that basically means is we're paying like 5 to 10 times more for bridging today than we need to, because that means, you can see how this kind of trickles up, right? So it's like, if we're bridging 5 to 10 times more, it's because LPs and solvers and market makers and centralized exchanges are rebalancing 5 to 10 times more, right? And if they're rebalancing 5 to 10 times more, that means they're charging 5 to 10 times more for their basic services than they would have otherwise. And then that kind of trickles up the stack till it gets to the user. And so that means the user ends up paying that way higher amount, which is kind of wild if you think about it.
Yeah, it is wild. I mean, the bridge experience of going from one chain to another, when someone else is just doing the same thing back, why can't we just take care of that on the chains themselves? Like, that's a major unlock. And the entire time you were describing this, like, my dad is an accountant, and so this is like an accountant's wet dream to like just net everything out and debits and credits just match up. It's like, yeah, like it'll just everything will net out and it'll be more efficient. And this is essentially like an accounting thing, right? Like,
It is.
so you guys are managing debits and credits from all these different accounts, and then ultimately you're going to have this method of netting everything out on the clearing layer. Does this mean that like fundamentally we're going to be taking less bridges? Because one view of chain abstraction is that we'll still use bridges, but the users won't use them. It'll just happen behind the scenes. And so, do you kind of tend to agree with like that vision of the world, or do you think like we won't even really need bridges because these solvers will just fill the thing, and we won't really need to take the canonical paths or like the general messaging paths, because we'll just have this intent-centric like solver view of cross-chain?
Yeah, let's talk about chain abstraction, because I think that will help clarify this a lot as well, because I think the notion of bridges is very overloaded in the space. And I think a lot of the challenges that we see today with bridges, like unreliability or like high costs or like lack of support for a lot of different chains, like all of it seems to boil down to a few fundamental issues. And like those issues are why chain abstraction and why intents need to exist. So I guess let's talk about bridging in general, right? So in 2021, when the space started conceiving of like bridges as like a thing that everybody was using on a day-to-day basis, no one really had their arms around like what this stuff should look like or how it should work. We had the benefit of experience in that we were coming from like an L2 centric background. And so our philosophy around building bridges was always like, it should rely on the basic trust assumptions of rollups themselves, and it should not like add to those trust assumptions. And so our mental model was like, okay, the rollup bridge is the bridge. And what we are doing is just providing a user experience layer on top of it that makes that experience not have to go through Ethereum, basically, and not have to take 7 days. In contrast, a lot of other projects are coming from a background of like, well, there's, two L1 chains and we need to have these L1 chains communicate with each other, which arguably like was kind of the situation back in 2021. And for that model, right, everybody's mental model was like, okay, well, you'll need some validator set, no matter what happens, no matter what model you use, you need some validator set to attest that something that happened here, some message that was over here needs to go over here and that it's done correctly. So initially that started out in like custodial mechanisms, then it was like multi-sigs, and then you sort of like move higher fidelity, right? So you have like more centralized systems like a single custodial party, a multi-sig, a POS, network like Axel or something like that. And then light clients. And light clients are sort of like using the validator set of the origin chain or the destination chain. Now, all of these are effectively doing the same thing, which is just like using some validator set for security. What's really interesting, and this is something that we kind of had an intuition for, but I'm realizing the rest of the space didn't really, because this was a specific discussion around L2s and around how L2 development. What we realized was like, if you are for this base layer of just let me get some data from here to here, which is the underpinning thing that sits behind like fund transfer and like apps and whatever, right? For that base layer, the more you secure the base layer, the more validators are involved in securing a message, the more expensive it's going to be. That's like, if you kind of think about it that way, it's not very controversial, right? It's like, this is the fundamental blocker for L1 blockchains as well. This is literally the blockchain scalability trilemma. Is like, the more decentralized you make the system, the more secure you make the system, the more it's going to cost, the less likely it's going to scale. This is where we are today. If you look at like if you look out at like the bridge landscape, you're kind of seeing people are starting to specialize. So like, projects that were in the past sort of targeting I think this is one of the big issues with cross-chain back in 2021 and still kind of persists to this day. Is like projects just didn't know what to target or what this stuff looked like. So they just said, we're just going to do everything. And so like projects like that tried to do everything, we're just not able to kind of focus on like one specific piece. But over time, we've started seeing that like, for example, Hyperlane has like specialized on message transport, which is just let me get data from here to here, and then you can plug in whatever security module you need. Layer 0 has also kind of gone in this direction. However, what you notice when you do this is like, okay, well, if I try to send a layer 0 message from one chain to another and it's secured by a light client, it's too expensive to be usable, right? It's or at least as part of the normal user flow. And I think that this is one of the like key challenges that like limits the ability for transport protocols like layer 0 to actually be used in applications. And this is why like most of the apps that are running on top of layer 0 today are using a much less secure approach, simply because it's just too expensive to use like Polyhedra's light client everywhere. This is not really like shade towards them or anything like that. I think it is the right move to have modular security, but it's just a fundamental limitation, which is like security costs money. And in the same way that like security costs money for L1 blockchains, and so we shouldn't have normal day-to-day activity happen on L1 blockchains, we should instead have an L2 where things are happening. We should batch up a bunch of transactions and only put proofs on L1. That's exactly what the idea behind intents and chain abstraction is, right? Chain abstraction is the L2 to bridging, effectively. Right? The whole hypothesis behind chain abstraction is we actually, for rollups at least, we have very secure bridges. The rollup bridges are like have already solved this problem of how do you get like canonical assets, how do you do the like baseline secure message passing. But in order to make them usable, you need an L2. You need something that allows users to like do very fast interactions between chains. That is like limitless in terms of scale, right? That scales out horizontally infinitely in the same way that like rollups scale out horizontally infinitely. And then you just settle back to the underlying bridges. You settle using the underlying messaging protocol that allows like an intent solver to get repaid. This is kind of the way that we think about this space. And when you start seeing it from this perspective, and I think like most of the chain, I think really all of the chain abstraction ecosystem is starting to see it from this perspective. When you see it from this perspective of like chain abstraction is the L2 to the transport layer is L1, you realize that something like clearing must exist, right? There's otherwise no way to kind of provide this experience. Like, we're not going to be able to provide a bridge experience that's actually satisfactory until you can separate out like the lower level security pieces from the user experience.
Welcome aboard on our journey into the singularity. This is the endgame roadmap for Frax and Fractal, the new L2 out of the Frax ecosystem that is totally based on fractal scaling. Fractal is a modular L2 blockchain built by Frax with modular and fractal scaling in mind. Fractal scaling is based on the Mandelbrot set of fractal images, and it explains how L2s become L3s and the entire app chain lifecycle goes through its evolution. The Frax ecosystem is made of some of the top builders in the space and has stemmed from its OG days of the Frax stablecoin. It is now in the LST space, the LRT space, and this Fractal L2 joins the existing suite of Frax products, including Frax Swap and Frax Lend. You can see Frax Ferry, the bridge to go from any chain, Arbitrum, Optimism, or mainnet into the Fractal mainnet, bridge your tokens, and bring your Frax assets into the Fractal ecosystem. Join today to get the best out of Fractal. You are still early. Join today, take part in our expedition into the singularity.
Makes total sense. And, when we're thinking about like this clearing layer and how it's really built for L2s, and this like almost has to be done. And then these general messaging layers and transport layers more built for L1. I'm curious, like, just to double click like even more on like the how. Like, we have this clearing layer, and I think coincidence of wants is like a great mental model for like how these things get netted out. And so I'm curious like what the integration process looks like. If it's like an account at like a user level opts in to this clearing layer, and then they can start to solve, or like, and maybe it's not or, but it's an and, the solvers also opt into this clearing layer and then get netted out against these other solvers. Like, when you're thinking about where to bring in the accounts that live on all these different chains, you start to get this like accounting landscape or ledger, I guess, right? Which is made up of all of these accounts on different chains. And so then you're starting to pull in the state of the blockchain, or at least the state of the accounts on these different chains. I mean, that is like a problem that I think lots of people are trying, like the shared sequencers, the composers, like all of these chain abstraction protocols are really trying to tie together and get a comprehensive look at the state of multiple blockchains at the same time at like one vantage point. So when you're thinking of pulling in state or pulling in account state from multiple different chains, how are you doing that? And like, how are you able to sync up the state of multiple different chains when some of them have different block times, some of them might get reorged, right? Like, how are you able to reconcile the state of all of these chains?
Yeah, it's a really good question, specifically because this gets into the exact problem that I talked about, where it's like, if you want to avoid these hurdles, you have to add latency, right? You have to like, you want to avoid reorgs, you have to wait time. So you can have like pre-confirmations and things like that, but you can't have like an entire protocol relying on that because it could just be easily attacked. The answer to your question for us specifically is that we don't. We actually, and this was an explicit decision. It was a hard decision because, it's like when you're building a protocol in this space, like you're sort of making bets on like, where is the market, and like who is going to be the user, right? And so like there's a very obvious user group of people, like individual users, traders, etc., that want to transfer between chains. Like everybody understands that market. But the market that kind of sits behind that of like, okay, here are the service providers to that market is still relatively newer. We are making a bet on that secondary market, which is that like, yes, there is additional risk. There's downside to like previously Connext, now Everclear, to like give up on focusing on like the end users that are making the transactions. But our philosophy is that like that needs to be solved higher up in the stack. We think like approaches like one balance or like magic spend that like Socket has been talking about, like basically mechanisms within a smart account to lock funds within that smart account conditionally based on some intent being solved. That is the right way to do it, because that's like within the user layer. And then because it's within the user layer, the user sort of like permissioning this themselves, you can make that very trust minimized. You don't need to have like communication between blockchains. You can just read the state of a bunch of blockchains, and the user can be like, okay, I'm okay like locking up my state within the UI because there's something within the UI that's saying like, I'm committing to making this transaction, and if it doesn't go through within only if it doesn't go through within a couple of hours will it get reverted back to me. That to me feels like the only way to kind of overcome that complexity. Now you've mentioned a bunch of other things like shared sequencing and things like that, right? So it's like the user, the flow that we kind of see is like user kind of blocks over their state or something like that to like express their intent to do something. A solver goes and fills that. So the user's interaction at that point is done, and like, we just don't have to think about the user anymore, which I think is a really, really good outcome. The solver can like batch up a bunch of these interactions and go and figure out how to settle, and they can settle with Everclear. How that settlement happens is where things like shared sequencing plug in. So like, for example, this is one of the open benefits of Everclear is that even beyond the netting, which I think is the immediate benefit, the secondary benefit is that the system is effectively like a settlement aggregator. Not really an aggregator, but basically it's a settlement negotiator or coordinator. The system plugs into like shared sequencers in different ecosystems, or things like IBC for Cosmos, or things like, say for example, like the token that's being settled is an OFT. You can plug into layer 0 for that, right? The idea is that there's like actually like an unbounded open design space around how to optimize settlement. For example, like tokens are kind of doing this all the time right now, where like a token may work with a bridge protocol to get bridged into certain ecosystems, but not others. It may use canonical bridges for some ecosystems and whatever. What that's doing is basically creating a really fragmented backend, like settlement backend, right? So like Frax is a really interesting example of this, where they've just had an evolving strategy, and like it completely makes sense. I think on some chains they've like issued Frax using canonical bridges. In other chains they've done it using Frax Ferry, and then other chains, like a few other chains, they've used Axar, and now they're looking at other things as well. If you're an intent solver, how do you rebalance that? Right? So it's like a really interesting and open question. Like, how do you rebalance that optimally? The answer is you don't really, right? Like you would have to basically go and take your funds, bridge them to Ethereum, bridge from like Linnea to Ethereum using Axelar, which is the canonical bridge for Frax there, and then bridge to using Frax Ferry to some other chain. And like you're paying ETH gas fees at that point, it's just not worth it at all. The idea with Everclear is to be able to go and like negotiate these things. So the way that it can negotiate that is saying, okay, this solver made a transaction go from, Arbitrum to Linnea, where Arbitrum, the canonical minter of Frax and Arbitrum is Frax Ferry. The canonical minter on Linnea is Axelar. But what the protocol can do is it can net off a transaction that's going from like Scroll to Linnea, which are both supported by Axelar, or Scroll to like Polygon, right? Where similar situation, Scroll is supported by Axelar, Polygon is supported by Frax Ferry. It can basically net off those two things against one another such that it looks like two separate transactions, right? It looks like one Axelar transaction going from Scroll to Linnea and one Frax Ferry transaction going from Arbitrum to Polygon, and none of it needs to touch Ethereum. And the more we look at it, the more we realize this is actually everywhere in the space. It's a huge fucking problem.
This looks a lot like extensibility, where bridges had this really this really pressing issue where they weren't able to reach all of the different chains. And so we continue to see more app chains come out, more rollups. That's like, it seems like that's only continuing in the direction of more rollups, more app chains. And so these bridges had a real problem. That was part of the issue with Connext, was that you weren't able to reach all of these chains and with all of these assets, right? And so now you were able to solve this bridge extensibility issue by going and saying, no, we're just going to solve it one layer above all the bridges can still operate. They can still go. They'll end up, through a various amount of bridges, they'll end up reaching chains. But then you have this clearing netting like layer on top that says we're just going to people are already taking the bridges there. We're just going to net it out so that finality happens quicker and at better execution. And so the end beneficiary is the user, because they don't have to wait or even take the bridges themselves. Like that'll just happen underneath this clearing layer. And so the user ends up getting their tokens quicker and more affordably. And then
that's on. Oh, go ahead. Sorry. Go ahead.
Just then by virtue that you're able to reach all of these chains that the underlying bridges can't reach themselves.
Exactly. That's a big part of what we're kind of like interested in here, is that, I mean, there are hundreds of chains coming. Like, I think people don't realize, like, I have talked to so many teams that are building rollups, and like so many more than you would expect. Like I would say just about every project in the space at this point has talked about it internally, or at least thought about it internally. Why? Because in many cases, a lot of projects are either already doing it or already doing a bunch of stuff that is like similar. So any infrastructure project, like Connext included in the past, like, we iterated on our design for several years. And when we looked really closely at our design last year, we were like, wait, this is a rollup. we built a rollup. We didn't even mean to build a rollup. We just ended up building a rollup. And like, and then it kind of like the light bulb went off, and we were like, okay, well, why don't we just use an existing rollup stack instead of like building a totally custom thing? And I think I've heard that story from a lot of different people in the space. So that's like all the infrastructure protocols. And then all the DeFi protocols have this similar problem where they're like, well, okay, there's going to be hundreds of game chains. There's going to be hundreds of different things out there that like ecosystem specific chains, things like that get spun up. Like, am I really willing to go and redeploy my protocol and bootstrap liquidity on each and every one of those? No, it just doesn't really make sense. And so, you have pioneers like Frax that have kind of realized this and are like, you know what? Let's not do that. Let's consolidate all of our liquidity on one chain. Fine, there's some fragmentation. We can fix that using bridges and intents. That user experience will get better. But our liquidity is going to be in one place. And because it's one place, we can provide the best possible pricing compared to competitors that have just spread out all over the place. Our philosophy is like, I think I'm actually willing to make a very solid bet that there will be, 1,000 rollups next year at this time. And not there, obviously a lot of them will be quite small, but I'm willing to bet that will be the case. And I think in that world, you have to kind of ask yourself, well, like, there's 1,000 rollups and there's 350 days. How are bridge projects going to deploy 3 rollups a day to get to that point? And I think the answer is that they're just not, right? Like, I think we have gotten to the point where we were like, okay, we can do 1 per week. And that was just like operating super efficiently. I don't know how you can speed that up beyond making, your bridge totally permissionless. And if you want to make it totally permissionless, that's what Everclear solves, right? Like, Everclear can go and be the like canary deployment into all of these ecosystems. We're working with all the RAS providers. Like, you just permissionlessly deploy Everclear. There doesn't need to be any liquidity or anything attached to it. You can deploy it to a chain or to a new rollup. And then that can be the base layer on top of which like dozens of intent protocols can just launch very easily.
The extensibility problem that you guys are faced with, you're confident that with Everclear's clearing layer plus a network of solvers or intent-based protocols, that is like the solution for this extensibility problem for the interoperability space.
Genuinely, I mean, I spent now years thinking about every single option, right? Like ZK proof singularity, shared sequencing, like those things are super important. And they are very critical aspects to how we will improve interoperability, but they will be latent, right? Like ZK proofs are like, if you want to have single slot finality, instant transfers across all chains at all times, like using only ZK proofs, we need to have proofs that are generated for all, like indexing all chains and the data of all chains that happen in faster than Arbitrum block time. So 100 milliseconds. I mean, I don't know how quickly we're going to get there. It can take 100 milliseconds to just communicate like across the internet today. It's like, yeah. So I think that like, if we really, really want to solve this, we need chain abstraction, we need intents, we need the L2 of interoperability. And if we have an L2 of interoperability, we need a shared sequencing of interoperability, which is effectively what Everclear is.
There was something that Andy mentioned on our last podcast just before this with Stefan from One Balance. and it was like let's take this to its logical conclusion. 1,000 rollups by maybe next year is fun. Like there's going to be way more than that, right? And so Stefan was like, basically, no, like every user is going to be its own rollup, right? And like I like now that I'm starting to wrap my head around that, it's like, well, with proper extensibility, that's possible. And so like the question was kind of like, well, okay, if I'm buying coffee at Starbucks on my account, then why does that have to tap into like the global state of like everything everywhere? Maybe it doesn't, and maybe we localize consensus and net out, like my transaction with Starbucks versus like, Starbucks and Starbucks' roll up or something like that. How do you think like something like that local consensus could look like? Is that how do you kind of like see that playing out on some of these more like cluster type of roll up structures that don't necessarily look just everything trickling down to L1 settlement?
I mean, ultimately everything will trickle down to L1 settlement, but it's just a matter of like when and how that happens, right? And like I like this buying coffee at Starbucks analogy, because I think that there is a very, very direct analogy that you can make to like the way that payment systems work today, where when you go and you buy a coffee at Starbucks, like Visa doesn't actually move your funds. That would be insane. Like it costs a lot of money, and it's really complex for banks to actually settle between each other. Swift and like Fedwire and like ACH is actually, I mean, ACH is a little bit more efficient, but it's still like not an easy process. It still costs a lot. I think to the tune of like $15+ per transaction. I think that I think for like a day-to-day payment where you're buying something for dollars or perhaps less, you need this mechanism, which is kind of how Intense works, where like some actor, in this case Visa, goes and like authorizes the transaction, basically says, I'm going to put my own credibility on the line, and like I'm going to just like, I know you have the money, and I'm just going to like tell the merchant, hey, you will be paid at some point. And then the merchant at the end of the day goes and says, hey, like here are all of my receipts. I'm going to ship them off to Visa. Visa collects all of these transactions, nets them off, and then goes to the banks to like negotiate the settlement. This kind of two-phase approach actually exists everywhere in systems. I think like it's interesting because it's like you talk to people in a bunch of different like ecosystems with or not ecosystems, different sort of like perspectives. There's some people that have a finance perspective, some people that have like a distributed systems perspective, a cryptography or information theory perspective. In all of these cases, you have the same overarching pattern of like when you want to make updates to the some shared state or a system that involves some shared state, it is like there is always like layers to how those updates are made. This exists for like clearing and settlement. It exists for like databases with caching, like both reading and then also writing into a cache. And then it also exists for things like commit reveal schemes, right? Where you don't want to like you want to like compartmentalize who has access to which information at what times. I don't think that model is going away. Like I think what we are doing in crypto, as we always have been, is like just rediscovering the same core principles and like running up against the same like fundamental artifacts of nature and physics that we're like, okay, we have to do this. There's no other option for it. I think like so to answer your question, Robbie, like basically like what we need to do in order for the system, for like if we want to maximally scale Ethereum, right, which we do, we want to get to the point where there will be like quadrillions of transactions per day on these chains. If we want to get to that point where you can run the entire world on this computer, how do you scale it maximally? Well, you have to have like tiers of consensus, where you have the baseline maximal consensus, right, which is the settlement layer. And that is the most secure form of consensus you get with the largest amount of participants. And then you have like sort of modularity, right? You have certain aspects like data availability where you can have a smaller security set because it just isn't as important. And you can kind of move up the stack to rollups that have an even smaller security set because they're not as reliant on like they're inheriting security from stuff underneath. And then as you move up the stack, I think to Intense, with Intense, what's happening is it's actually even smaller. There's no like public verifiability at all. An intent is basically a one-to-one relationship. We call this locally verified when we first like talked about like the interoperability trilemma back in 2021. I think our understanding of this has evolved quite a bit, where we sort of see now like local verification is a slightly different thing than the other forms of verification. But local verification just means like, okay, no one else needs to be involved in verifying this. Like I trust you because I know you have money on the line. And like I can verify that myself. And that's super easy for me to verify like in the browser. I just verify a signature and that's it.
Very cool. Yeah, makes a ton of sense. Andy, did you got something there?
Yeah, I just think this like tiered approach to consensus is like is something that we're just gonna slowly get to. So, kind of excited to see that roll out. I think like the last thing that we should touch on is just kind of how the development of the clearing layer is going, and just kind of what the next couple of months look like for you guys.
Yeah, that's a really good question. So I mean, we're live on testnet as of the announcement, which is awesome. I think like um, I think for us, we're a team that like really believes in having something tangible before we start talking about it. So it's nice to be in this place where we have something that people can start like interacting with, and we're already talking to a bunch of protocols. It's like a really awesome ecosystem of folks that have like been interested in this, and it's fantastic. Like a testament to how positive Summit is that like all of that ecosystem is made up of all the protocols that were previously our competitors, right? So like it's really great that like they're all just like, yeah, everybody has this problem. Like we don't know how to solve it. We don't want to solve it. We're focused on this other much more important thing, which is totally fair. We'll do the next. So we're basically from here. There's a few things that we're working on. We have a initial kind of V0 implementation for how like the pricing and netting works in the system that we talked about as part of like the launch thread and blog post that uses a Dutch auction. In the longer term, the idea is, as I mentioned, like settlement is this like has unbounded complexity. So what we want to do is just like allow for anyone to build their own strategies for settlement and have them compete, where like solvers can just opt into like what the best strategy is. This is really cool because I think like there are like the ideal outcome to head towards in this case is something that's like truly data oriented, right? So you can use data to not only like optimally net between partners, but also like preemptively figure out where should liquidity go or where should we have deposits available to accommodate for future netting needs. And that is a like data science machine learning problem, which is very interesting. I have a little bit of a background in machine learning as well, as does Lane. So this is something that piqued our interest a lot. So I think the direction I expect this stuff to head is basically like eventually get to the point where people can build any kind of like arbitrary settlement that could maybe do something like post like a zkML proof of computation over like historical data of flows into and out of Arbitrum to figure out when are we going to see potentially like an increase in flows or something like that. And then in addition to that, plugging into stuff like CCTP for USDC or FraxFerry for Frax or whatever. What we are doing between now and launch is like working on kind of finishing development of the Dutch auction system and like kind of getting feedback and testing of that, and then starting to think through the designs of like what does this other piece look like. And then aside from that, just like the basic stuff of like audits, security reviews and other things like that, getting feedback from partners, etc. We're targeting going live in sometime in Q3.
Awesome.
One quick question for you, and I know we could have a whole nother conversation on this, but like maybe just at a high level, like the ME, like again, like the layered consensus thing. Does that open up MEV at each layer? Like generally, without getting too specific, like how are you thinking about MEV in this new paradigm?
Yeah, it's a really good question. So there's MEV kind of a little bit higher up in the stack, and then there's like how this problem at the Everclear layer. Higher up in the stack, there is so any instance where there's like information asymmetry, there's MEV, right? Like you can any instance where you just some people have access to information before others, you can like take advantage of that information. The idea with like intents and intent networks is that the more you can get to the point where there's like a single like unified public auction where everybody's expressing their intents, the more likely it is you can have an outcome where there's like fairness, where there might be like opportunities to front run, but everybody becomes aware of those at the same time, and so then it's not as much of a problem anymore. But then the flip side of that is also true, where it's like if you have for like certain kinds of use cases, like it's just better to not have that option at all and just have things be in a private option. That's like I think a really interesting and ongoing area of research. Anoma's doing a lot here. I know Suave is thinking a lot about this as well. To be honest, it's like a little bit out of scope for us. So we're sort of like we're keeping an eye on it as something that's really interesting, but we're more interested in like what does this mean for solvers? So for solvers specifically, it's kind of there's sort of this like interesting situation where solvers want to like net off against one another and reduce their costs, but they also like solvers are necessarily adversarial, right? Even if they're not all like friendly to each other, but like they are adversarial actors economically, and they're like competing with each other on filling these intents. And so if a solver is like preferentially being settled to in any way, then that's a form of MEV, because basically that means that like some solvers over the long term are going to win out over others. For this, one of the key design elements of Everclear, so Everclear is an arbitrum orbit rollup, and it's like working fraud proofs and things like that. And one of the key design considerations around it was we want to make sure that everything that the system does, both like now that we're building it ourselves, and then also in the future when people come and like build their own settlement strategies, we want to make sure that every single thing that the system does is publicly verifiable. And in this case, publicly verifiable means like it's posting a proof to chain of like, okay, a bunch of intents came in and a bunch of solver settlements came in. In our system, we call these invoices. So a bunch of invoices came in. Those invoices have to be processed in order, because if you break that order, then you're kind of unfairly settling some people before others, and they might be getting better pricing. And so, you can verify that ordering. You can verify like the strategy that is used, because there is a proof posted by the rollup to chain. And if the ordering is wrong, then that's a fault of the rollup, right? Like, and that's something that is slashable just per like normal arbitrum orbit rules. For us, I think that's like a really important piece. Now there is like one other piece, which is how does the system even ingest new intents to begin with, and are those ordered correctly? That's one which is actually a much harder problem that, to be honest, I think there's one team that we've been talking to about it that maybe potentially has a solution. But I think that's one which actually requires like encryption, where we have to sort of actually actively like hide information associated with the inbound invoices going through like Hyperlane, for example, into the system. Like when Hyperlane, like we use Hyperlane to kind of read new intents or new settlements for solvers coming from every chain. We would perhaps even need to like privatize that, such that there is no way for someone to know, okay, well, these settlements are going to be ordered in this way, and so I could potentially try to run them. Anyway, TLDR, it's a very, very hard problem. I don't know if there is a single silver bullet solution. I think a lot of it is just going to come down to like management and like continuing to find ways to like compartmentalize information in the right way.
Awesome, man. Appreciate you staying a bit longer over time and answering our questions. Congrats on the launch, man. It's been really impressive to see Connext into Everclear and beyond.
Thank you so much. I really appreciate it.
Yeah, thanks for coming on. Always a pleasure, sir, and looking forward to the next couple of months. Got a lot going on, and see you in Brussels.
Yeah. See you guys in Brussels. I think it's
the beer.
Yeah. For anyone that's listening, we're going to be heavily involved in ECC, and so if you're going to be there, definitely come and say hi.
Hell yeah.
We will see you there.